In last video we have solved one problem based on beta function. The next problem based on beta function is this, that is integral 0 to 1 1 minus x to the power 1 over n raised to m dx, and we want to prove this is equal to n factorial into m factorial divided by m plus n factorial. Now if we compare this with the definition of beta function, x term is x to the power m minus 1 term, this is missing here, and the one term is present here, and instead of 1 minus x I am having here 1 minus x to the power 1 over n. So clearly I am going to substitute here x to the power 1 by n is equal to t, right? So let's try to figure out what must be the value of dx. Differentiate this equation. So this is 1 by n multiplied by x to the power 1 by n minus 1 dx. This is equal to dt. I will simplify this. This is x to the power 1 minus n divided by n into dx is equal to dt. So what is the value of dx? This is n divided by x to the power 1 minus n into divided by n into dt. Now note that what is x? From here I can conclude that x is nothing but t to the power n, correct? Here I am having x to the power 1 by n, so this is nothing but t to the power 1 minus n. So this is n divided by x to the power 1 by n is t and raised to 1 minus n and dt, correct? And if I write down this in the numerator, I can write down this as n into, this will be t raised to minus of 1 minus n, so I will write down this as t raised to n minus 1 dt. Okay, let's check out the limits now. What are the limits? So this is x is running from 0 to 1. So when I am substituting x is equal to 0 here, t is clearly 0, so lower limit 0. When you are substituting t is equal to x is equal to 1, t is also 1, so upper limit is 1. Let's see what is now the new integral. So integral is 0 to 1 1 minus x to the power 1 over n. This will become 1 minus t raised to m and multiplied by dx. Dx is n into t raised to n minus 1 dt, right? N is just a constant. Take it outside. So this is 0 to 1 1 minus t raised to m into t raised to n minus 1 dt. If we compare this with the definition of beta function, what we have, this is n into beta of x ka power, that is n minus 1, and add 1 to that, that is value of m. So this is n into, this is m plus 1. And this is nothing but n multiplied by, this is gamma of n into gamma of m plus 1, and this is divided by gamma of n plus m plus 1, right? Addition of these two. Then what is it equal to? N into gamma of n is nothing but n minus 1 factorial. This is multiplied by m factorial, and this is divided by n plus m factorial, right? And we know n into n minus 1 factorial is simply n factorial multiplied by m factorial and this is divided by n plus m factorial, and which is a required thing. Okay, you can verify.